In this video, I'm going to talk about quartiles and the 5-number summary. So let's first start with quartiles. So the root of the word quartile, quart, means 4, and quartiles are numbers that divide a data set into 4 equal groups. And if you think for a second, I'm going to just draw a picture of a rectangle. Imagine that this rectangle was like a cake, and you wanted to cut this cake into 4 equal pieces, 4 equal rectangles that were the same size. How many cuts would you make? Well, if you cut it down the middle, that would cut it in half. And if you cut this side in half and then this side in half, you'd have 4 equal pieces. So how many times did I cut the cake? Well, I cut it once, I cut it twice, and then I cut it 3 times. So basically 3 cuts equal 4 sections of equal size. So that's essentially what a quartile is. So the second cut, that's what we call Q2. That's the same as the median. So it cuts the data set in half, in an upper and lower half. It means 50% of the data fall below, 50% are above. It's directly in the center. This first cut, so the middle of the lower half, we call Q1. So it's the median of the lower half, and 25% of the data fall below the first quartile, 75% are above, because each section is 25% of the data. And then the third quartile, which is this third line, we'll call this Q3, that's the median of the upper half of the data. So 75% of the data fall below that. Each section is 25, 50, 75 are below, and then 25 is above that quartile. So in general, for any set of numerical data, 50% of the data are below the median. So the median is always representative of the 50th percentile. So you could even jot that down here where it says median, 50th percentile, because those represent the exact same data value. And then the quartile, Q1, that's the 25th percentile. And then Q3 is the 75th percentile. And we use these values to describe a data set. And so let's look at a couple of examples and calculate these quartiles. So in example 1A, we're going to find quartile. We're always going to start by finding quartile 2 first. So the first step is we put the numbers in order. The numbers have to be in order. Then once the our numbers are in order, we're going to find Q2 first, which is just the median. So you should know how to do this already since we've done the median before. So you start with the outer numbers and you just work your way in. You can take your left finger and a right finger and just kind of work your way in until you get to a middle. And I find a middle between 5 and 8. And if you ever arrive at, a spot where it's between two numbers, you just add them up. So 5 plus 8 divided by 2. So 13 divided by 2. And so I get 6.5 there. And so 6.5 is going to be the median, which is also Q2. The key here is that you do not include the middle number when you're finding the middle of the lower and upper halves. So you almost act like these are, imagine these being brick walls here. I'm excluding Q2, I'm not including it. So now I'm going to look at the lower half and I'm going to find the exact middle. Well, the exact middle of the lower half is between 4 and 5. So I could add 4 plus 5 divided by 2 or 9 divided by 2 and I get 4.5. So 4.5 is going to be Q1. And remember, that's the 25th percentile. And then I'm going to find the middle of the upper half, which is between these two 9s. Since they're both the same number, we say that it's just 9. I don't have to do any computations there. And Q3, remember, is the 75th percentile. Okay, so let's look at this next example. It's nice to do a few because depending on the number of numbers, you can have some different things happen. So I check that my list is in order, which it is, and then I find the middle. So I've got 1, 2, 3, 4, 5, 6, 7 values, so I'm going to have an exact middle. So if I go 3 in and then 3 in from this way, I get an exact middle of 5. And so that's going to be my Q2, which is my median. Now, just like before, I make my brick walls here. I'm not going to include that number when I find the middle or the median of the lower and upper halves. And so I look at the lower half and the middle is 4. I don't have to do any computations there. That's my Q1. The middle of the upper half is 9. So that's my Q3. All right, so let's look at the next data set. So this one we have 1, 2, 3, 4, 5 values. So it has an exact middle, which is 5. And then just like before, I make my brick walls here. I exclude the median. So let me write down that this is Q2 or my median. And then I find the middle of the lower and upper halves. And so the middle here is between 3 and 4, which is just 3.5. If you need to add 3 plus 4 divided by 2 in your calculator, you could do that to get 3.5. And then 5 plus 8, you could figure out what number is in the exact middle of those. And if you add those up and divide by 2, you end up getting 6.5. So 6.5 is Q3 and 3.5 is Q1. Okay, last example. So in this example, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 data values, so I'm not going to have an exact center here. So I'm going to go 1, 2, 3, 4, 5 in. And then 1, 2, 3, 4, 5. So I have 5 numbers on either side of my line. This is going to be my Q2. So I'm going to have to add 8 and 9 together, or just look at these numbers and say, oh, well, 8.5 is in the middle. So 8.5 is my Q2. That's my median. I am not going to include 8.5 when I find the median or the middle of the upper and lower halves. Now, keep in mind, I did use 8 and 9 to find the median, but those are not the medians. So I can include those when I find the middle of the upper and lower halves. I'm just not including the actual median itself, which is 8.5. So then I'm going to look at the middle of the left half, and the middle is exactly 5. So 2 on either side. So this is going to be my Q1. And I look at the middle of the right half, and this is going to be my Q3. Okay, so let's do one more example. So suppose we have measured 9 females and their heights in inches, sorted from smallest to largest. And I've got their inches listed here. Give the 5-number summary for this data set. The 5-number summary gives the minimum, so these are the 5 numbers, the minimum value, Q1, the median, which is Q2, Q3, and the max. So the 5-number summary are basically those numbers listed out. And so I'm just going to identify what they all are here. So the minimum is going to be 59. Okay, the maximum is 72. I always like to do those first because those are the easiest. And then I find the middle. So I'm going to do the middle next. I always want to find Q2 before I find Q1 and Q3. So if there are 9 females, that's great because I have an exact middle. So I'm going to count 1, 2, 3, 4, and then 5. And so this one right here, this number, 66, will have 1, 2, 3, 4 on the right and 4 on the left. So that's the exact middle. And you can also just take your finger or your pencil on either side and just work your way in until you get to the middle. And so that's going to be the median, or Q2. So Q2 is median. And then I'm going to make my brick walls here because I want to exclude the median when I find the middle of the lower and upper halves. So now I'm going to find the middle of the lower half, and it looks like it's between 62 and 60. So I could add those up and divide by 2, or I could just ask myself what number is in the exact middle, and it's 61. So that's going to be the Q1. And then I'm going to find the middle here, which is between 69 and 70, which is 69.5, and that's my Q3. And you can also just do, if you weren't sure, just add 69 and 70 and divide by 2, and you'll get 69.5 that way. So our 5-number summary is 59, 61, 66, 69.5, and then 72. And what we can do here is I want to show you how you can sketch a box and whisker plot for this data. And to do that, you have to start by drawing a number line. So I'm going to draw a number line at the bottom. And it's really up to you how you want to label the number line. You just want to make sure you label it in a way where all of your 5-numbers from your 5-number summary can be graphed on this number line. So since my lowest is 59, maybe I'll start at 50. And so I'll go up by 5. So this is 50, 55, 60, 65, 70, 75, 80. So I'll go ahead and fill these in too. And so now that I have my number line drawn, I'm just going to plot a little point above each one of these numbers. So 59 looks like it'd be maybe about right there. 61, pretty close. 66, 69 and a half. You're just doing your best guesstimate here. I mean, it's hard to be super precise the way I have this drawn, but 72, maybe about right there. Okay, and so with the box and whiskers plot, the last two dots on either side, on the left and right, you draw a horizontal line. Those are like what are called whiskers, look like whiskers. And then the middle three dots, you're going to draw a box. With the very center dot, you're going to draw a line down the middle. And so the line down the middle, this represents the Q2, and you don't have to write this. When you plot your box and whiskers plot, you don't have to label it, but I'm going to label it here just so it can make some sense. This line right here, this was our Q1. This line right here, this was our minimum. This line right here is our Q3, and this dot right here is our max. And this basically just shows us how the data is distributed and spread out. Keep in mind that when we find our quartiles, remember that cake example at the very beginning when we cut the cake 3 times to make 4 sections, there's equal percentage of data in each section. So when we think about the plot, there's 25% of the data in this whisker, 25% here, 25% here, and 25% here. So if you see sections that are larger or smaller, that's just an indication that the data is more spread out in that region. It doesn't mean that there is more data. So say, for instance, you had a box and whiskers plot that maybe looked like this, where one section was really big and maybe one was small. It just means this is more spread out. So hopefully that helps you understand what quartiles mean and gives you a good visual for how we can use them to show a visual for our data set.